So one thing that we can talk about now are geometric series, and this is really this part is really should be reviewed because from Algebra 2 or from pre-calculus, you've already discussed geometric series. This is the idea that if I have an initial term and the next term I'm adding on in the series is the previous term multiplied by our common ratio r, we can act, even if this goes on infinitely, we can find what this adds up to, which is the first term over 1 minus the common ratio, as long as our common ratio is between -1 and 1. This is what's known as our interval of convergence. So here, I have an infinite series, 1 plus x plus x squared plus x cubed, and so on, where we're saying that our common ratio, which is x multiplied by x, is fine. Well, as long as x is between -1 and 1, because x is the same as r, and that's our interval of convergence for our common ratio, this would be equal to our first term, 1, over 1 minus our common ratio of x. This actually means that as long as x is between -1 and 1, this infinite series is equal to 1 over 1 minus x. Now, this is useful for us because in calculus, we can actually say that the derivative or antiderivative of a convergent series is also convergent. So if we take that infinite geometric series, the derivative of 1 over 1 minus x is 1 over 1 minus x squared. Well, if I take the derivative of the left side of this equation here, I have to take the derivative of the right-hand side. Well, derivative of 1 is 0. Derivative of x is 1. Derivative of x squared is 2x. Derivative of x cubed is 3x squared. And so on. I haven't done anything to change my interval of convergence. So as long as x is between -1 and 1, this infinite geometric series, or this infinite series, but this infinite series is the same as 1 over 1 minus x squared. Similarly, if I do antiderivative, the antiderivative of 1 over 1 minus x is the negative natural log of 1 minus x. Again, as long as x is between -1 and 1. It's important for us actually to stay within our domain for natural log. Well, if I take the antiderivative of the left side of the equation, I have to take the antiderivative of the right-hand side. So the antiderivative is x. Antiderivative of x is x squared plus 1/3 x cubed plus 1/4 x to the fourth, and so on. And what we now have is an infinite series that, as long as x is between -1 and 1, will equal the negative natural log of 1 minus x.